because we know percents kind of tend to get out of our heads, unfortunately, very quickly. So we're doing 1 through 27 odd on that. So let's just start with, I'm going to pick one that might look weird to people. I'm just going to pick number 3. You got 37.5%. Now, in algebra, we like fractions, but when we're doing percents, not so much, right? Because they kind of don't work as well. Couldn't I write that as 37.5%? Because what they want me to do is write it as a fraction in simplest form. If I want to write something as a fraction, and it's given to me as a percent, I usually change it into a decimal first, and then I write it as a fraction. It's just, we can represent things in different ways, and it tends to be a little bit easier. If I were going to write that as a fraction, and I put 37.5 over 100, would that confuse y'all? Because it would confuse me a little bit. Why don't I go ahead and write this totally as a decimal first? What would 37.5% be as a decimal? What do you do to change a percent into a decimal? Don't you scoot the decimal place? Scoot decimal, left 2 spaces, right? Okay, so this 37.5% would become 0.375, right? Because that would be the first step I would do. Because usually, no. Bad internet. Oh, thank you. Yes, it is not recording. Thank you, Luke. So I write it as 0.375, and then when I try to decide what to put it over with, I think this is the tenths place, then the hundredths place, and the thousandths place. So I put 1,000 on bottom, and then we said the quick way we could do that is to put a 1, and however many decimal places there are, that's how many zeros out. Yeah, we have to reduce the fraction. It'll divide by 5, but it'll actually also divide by 25. If you think about how many 25s are there in 100? 4. So if we got 300, that would be 3 times 4 is 12. Or you could divide this out in your calculator and hit math, enter. And then you got 3 more, so it would be 15. And how many 25s are in that? I think it's 40. Okay, but that still reduces, right? And again, you could have put it in the calculator, hit math, enter, and it should reduce. So 5 goes in there, 3/8. Thank you, Ethan. It would be 3/8. So you do want to reduce it all the way down. And I forgot to turn the recorder on again. Oh my gosh. So we just put the 360%. We put the 360 over 100. We didn't have to worry about doing anything weird because there weren't any decimals this time. And then we just reduce the fraction. And remember, in your graphing calculator, you can put 360 divided by 100. You get that decimal value, and then you hit math, and you hit enter twice. So I'm just going to put enter, and it should reduce it to that for you. That's what's so great about graphing calculators. Here we go. 17 is 0.5% of 300 is what number? Okay, those of you who had me for 7th grade know that I love proportions for percent because it gives you a place to put everything. I know that not all teachers teach that way, and I know the 7th graders this year argue with me that they don't need to do it that way, but it sure can help you in a problem like this. Calissa?
Isn't it 0.5%?
Oh, you're right. I got I mixed 2 numbers together, didn't I? This is right now, isn't it?
Yeah.
Okay. So now, I'm going to go ahead and teach you percents for those of you who didn't have it because a lot of times you're like, what am I supposed to multiply by what and how am I supposed to remember it? When you do percentages, what I like to do is use proportions because they work. And we use them so many places in math. It's just a tool we need to have in our math tool belt anyway, and it's so great because when you see a percent, doesn't that mean put that number over 100? Mm-hmm. So you're going to make 2 fractions. And one of them is going to be your percent fraction. So it's like a half. That's the same thing as 0.5. I could put a half over 100, or I could put 0.5 over 100. There you could do whatever you wanted to. Now, when you see the word of, well, if you're going to do it the other way, not using percent, that would mean multiply, okay? So I know I could do it the old way here. If you're using percents, when you see the word, proportions to solve percents, when you see the word of, that tells you there's your whole coming. Because remember, those of you who had me before, you make the percent fraction and it's part to whole, and then you have your number fraction and it's also part to whole because a percentage is part out of 100, so it's a part to whole. The whole is just always 100. But over here, if I know that the whole comes after the word of, and if you think about it, it makes sense. They're telling you, well, what's part of that 12 there? Well, 12 would be your whole. You want 0.5% of 12. You want a part of 12. So you can make your x right here. The thing about using proportions for this is there's a place for everything. When you see the percent figure, you put something over 100. And then when you get the of, the number that comes after it is your whole. If they're asking you for that part, that whatever's missing in the whole thing becomes your x. It gives you a place to put everything and figure it out without having to think about whether I multiply or divide. We'll do some more of these, but let's just finish this one out. When it's a proportion, I can cross multiply. What's 100 times x? 100x, right? What's a half times 12? What is half of 12? 6. You see how you can think about that and make that not so scary? What's half of 12? A half times 12 is the same thing as saying what's half of 12. It's just 6. So x is basically 6 divided by 100, isn't it? And that would reduce, because 2 goes into 6 3 times, and 2 goes into 150. 3 over 50. In the book, they're giving these things as decimals, as answers, which is fine. If I give it as a decimal, this 6 over 100 would be 0.06, wouldn't it? You do not have to solve these the way I'm doing them right now. I just think that a lot of people who struggle with percents wouldn't struggle with them if they would use proportions to solve them, okay? Because remember, if I'm going to use a proportion, I got two fractions. One of my fraction is the percent fraction, and I know what that is. It's this 20%. So isn't that just 20 over 100? It's a part out of a whole, and the part's 20 and the whole is 100. That's what it means to be a percent. It's put it over 100. And the other fraction's also going to be a part out of a whole. 8 is 20%. It's part of some other number, isn't it? And if I have a hard time figuring out that the 8 is the part, if you remember what I just told y'all that they hadn't seen this before, the of tells me the whole is coming next, and it's missing, isn't it? That's the part that's missing. So if it's missing, I'll call the whole x. I'll just call it x since I don't know what it is. And the part is 8. The word of, the other method, you know that's your multiply. But here, of course, that gets a little messy because the thing you'd multiply by is missing. So if I set it up this way, I don't have to think about whether to multiply or divide. I just let the proportion tell me what to do, and I just set it up part to whole on both sides. Of is going to always tell you the whole, so that's going to give away part of this other fraction over here, so it makes it easier. Well, whatever's missing, you just fill the number in the other part. Okay, so if we cross multiply, 8 times 100 is 800. 20 times x is 20x. I want to get x by itself. I divide both sides by 20, just trying to speed through this since we're kind of short on time. And if you divide that out, isn't it 40? So 8 is 20% of 40. That kind of makes sense, doesn't it? If you think about it, you can figure out, yeah, that is the right answer just thinking about it. So do y'all want to try? We've got time to run through one more. Y'all want to run through another one quickly, and then you can always look back at the video. Sure. Let's do 13 on the video if you need to go back, because if I'm going too fast, maybe you might want to. 32%. Ooh, that's a percent. I can stick it over 100. There's half of my proportion already, right? Just because I saw the percent on it and it was a number. Okay, I know that this other part's going to be a part out of a whole also. 32% is part out of 100, but I've got another part of a whole. That's how I'm going to build a proportion out of this. 32% of 300. Oh, the word of tells me that this is going to be my whole right here. So if I need to know how to arrange my other fraction, that 300 is going on the bottom because it's part over whole, and 300 is the whole. The word of is a key word that gives that away. 32% of 300 is what number? I'll just put, let's put x. What number? I'll just call it X. That's what's missing, and there's only one spot to put it. I filled in the whole because it was after the of, so that means that X has to go there. I really don't even have to think about it. It's the only slot missing. So when you do these proportions, that's what's nice about it. You can identify things pretty easily, and if you got a number and you're not sure where it goes, there's only going to be one missing spot to stick it in there. So it's kind of it helps you because you don't have to think as hard, honestly. So if I cross multiply, 100 times X is 100X. I'm going to set that equal to the other thing, cross multiplied. 32 times 300 is going to be, let's see, 9, 6 with 2 zeros after it. If I want to solve for X, I could divide both sides by 100. And that's going to be what? 96. Ah, my answer is 96.